Let's take a look at some quick examples of what we have available to us in our basic toolset for sheet metal parts. So we're going to start again with a new part inch file, and we're going to start a sketch on the front plane. Now on the front plane, I'm going to draw a U shape. So I'm going to draw a line down through the origin and back up. Now at this point, I don't really care too much about the dimensions, but I want to make sure that I add some dimensions just to scale this. We're going to make this line 4 inches tall, these two lines equal, and we're going to give this line a 7-inch wide dimension. We'll right click on it, select its midpoint, and locate it at the origin. So now we have a fully defined sketch. We're going to take this sketch, go to our sheet metal tab, and create a base flange. Now I have direction options. We can do direction 1 and direction 2, and we can determine how long we want this thing to be. We're going to say 8 inches midplane, so we go 4 inches in either direction. And we're going to leave all the standard sheet metal parameters. So you can see we took this basic sketch, even though it had square corners on it, and we created a nice sheet metal part. So if you have a sheet metal cross section that you can see from a single view, it's a quick way that you can create and collect a bunch of bends. Now the bends in these corners were based on the original, back in our sheet metal parameters, the original radius value. If we increase this, for instance to 0.25, it's going to modify how big these bends are. So that's one way that you can create a really quick sheet metal part. So now let's talk about some of our basic tool sets. We've already talked about convert to sheet metal, and we just use create base flange. We're going to skip over lofted bend because it's a little bit more advanced and there are a few techniques in there that you need to understand. But we will talk about the rest of our basic tool set: edge flange, miter flange, hem, jog, and sketch bend. We'll also talk briefly about corners using the closed corner option, and we'll even talk about sheet metal gussets. There's a lot more functionality to creating sheet metal parts, but it's really all in how you use it and how you understand the process. So let's get started by creating an edge flange. Now, as we saw before, edge flange simply requires you to select an edge and pull a flange in either direction. But there's one thing I didn't mention before. Inside here, we have an edit flange profile option. Now, when we do this, we get a pop-up that's saying profile sketch. We just need to simply drag it out of the way. If you have two monitors, you can drag it off onto another screen to get it out of your way. As we're looking at this, you'll notice that the top blue edge is underdefined. We can move it around, and this is essentially determining the length of the flange. But we have a lot more that we can do here. We can take these endpoints and we can drag them in, and it's telling us that our automatic relations are overridden because they're no longer coincident with the end. But that's not all we can do. We can also do things like modify angles of edges and even add a bit more detail. For instance, if we wanted this to come back in and jog back out, we can then create a very different profile. And of course, because this is a sketch, we can do things like create dimensions to points or edges, so that way we can still have a fully defined sketch. Well, let's go ahead and bring our dialog back over and say finish. So you notice now what we've done is we've created a new edge flange with a very different profile from just the standard edge. Now this is very important because as you're creating your sheet metal parts, you won't always have edge flanges that are exactly matching whatever edge or face that you're coming off of. So knowing that you can modify the original profile of that edge flange can go quite a long way. Next, let's talk a little bit about miter flange. Now miter flange requires you to have a sketch input. Now in this case, I'm going to select the top face, and I'm going to use the line tool, making sure that I'm intersecting the inside edge and the end vertex, and I'm going to draw a line that's 1.5 inches long. Now we can also do things like dimension the angle of this line to be 120 degrees. So now that we have a fully defined line, let's rotate this around to make sure we understand where this is located. So this point is the end of the inside face. Once we say OK, what we're now doing is we're creating this miter flange, and we can select more edges. We can carry this sketch profile all the way around the part to create a very nice edge flange all the way around the open side. Now, of course, you can always go back and modify parameters like the gap distance, where the flange positions in, if it's inside or outside of the original bend. And you can go back and modify start and end offset. For instance, if you wanted it to start 1 inch from that original edge and end 1 inch shy of the other edge, you can modify those parameters as well. Once we say OK, now we've created a nice mitered flange. The hem tool is pretty handy, especially if you need to add structure to your sheet metal parts. All we need to do is select an edge and modify our hem parameters. For instance, we can modify the hem width, we can change the material to go inside or outside, and we can also modify the type and size. For instance, if you needed a squished edge or a teardrop shape, these can be very different ways to add a little bit of structure to your sheet metal parts. Next, let's talk a little bit about creating a jog. To do this, first I need to cut some material out of our part. So I'm going to go ahead and create a sketch on the inside face and make a quick opening. So I'm going to start by just drawing this opening. And again, the dimensions don't really matter. What I want to make sure is that this line and this line are collinear. And I'm going to say OK. Now it says it's not suitable for a miter flange. That's okay. What we want to do is we want to go to our sheet metal tab and use it for an extrude cut. And we're going to say through all. So now that we have this cut, let's make one more sketch. Selecting this face, I'm going to come in using my line tool, and I'm simply going to draw a line across this flange. I do want to add a dimension here. I'm going to add a dimension of 0.5. Now this sketch is going to be used to create a jog. Now the first thing we need to do is select a fixed face. Now this is very important because in an instance like this, if we select on the right-hand side, SolidWorks is going to try to bend the rest of the material around that. So we want to make sure that we select to the left of that face. So as we're looking at it, you can get a preview of what's going on. But it's very important to understand that even though this looks like it works on the screen, once this thing is flattened, it will not physically be able to be created. You'll need more of a cutout around the outside in order to get this flange to work. But there's an option because inside of the parameters, we can turn off the fixed projected length option. So fixed projected length is very handy when you're drawing the cutout if you know exactly where you want that end face to land. But you do need to make sure that you do have enough material around it so that it can be folded. If we turn on or off the fixed projected length, you can see that we get a different option. But we also have some other things. We can determine where the offset is going to. We can modify how much the offset is. For instance, if we wanted it to be 1.5 inches, you can see it shortens that flange up just a bit more. We can also modify things like the angle it's at. Now this is a very handy tool for making things like latches that need to snap into certain areas or just relief cuts. You also notice that we do have custom bend allowance options, but again, these are more advanced topics and we're not going to be covering them in our video series. So now that we've created our jog very quickly and easily, let's take a look at sketched bend. Now, sketch bend is another very interesting case here. And what we need to do is we need to create a sketch, and the sketch needs to be on the face that we're bending. So let's go ahead and select this face, and we're going to draw a line. And this line doesn't really need to fall or intersect any edges. It's just going to be the location of a bend. I'm going to use that to create a sketched bend. Now again, we need to select a fixed face, and in this case, this edge is going to be fixed. And you notice that the arrow is pointing up or down. Now if we modify this, you notice that it's not really giving us a very good preview. If we say OK, it tells us that it failed to make the sketch bend. Now there's a very good reason for that. Sketch bend is looking for a very specific type of sheet metal face. Now something like this doesn't necessarily fall into that category. Now if we come back in here and we snap it to the corners, or at least snap it to the edges, we can hop back out and we can try to use it as a sketch bend, but you'll notice that we still don't really get a good result. So what we want to do is let's go back to the jog that we created. Let's modify its parameters. Let's bring it down to be 0.5 above. So now we have a pretty nice large flange. Next thing I'm going to do is sketch on this face. I'm going to draw a line. And again, the line doesn't even go all the way across the part or intersect it, but I can take that and I can use it for my sketch bend. I want to select a fixed position and notice how it's able to bend that lip up. We can do different things like modify the default radius value if we want a tighter corner, change what angle it's at, and even determine where the bend position is. Material inside, material outside, bend center line, and say OK. So again, this is a very quick way for us to make a different type of bend or edge inside of our sheet metal parts. Next thing we want to do is talk a little bit about corners. But in order to do that, I want to create one more edge flange. I'm going to create an edge flange from here and just bring it up to the top of our part. Next, I'm going to use the corners dropdown, and we're going to go to close corner. Now, if I select this face, you notice that by default, it automatically carries it over. Now, what it's doing is it's adding material to one of the faces and it's removing it from another. And you can determine how this bend is going to fall. If you want the corners to line up as an open edge, or if you want overlap or underlap, you can quickly and easily determine how this is. You can also modify the gap distance, any overlap or underlap ratios, depending on your actual selection. And then we also have a few options down here, such as open bend region, narrow corners, and so on. Now, once we say OK, you can see that material has been added to one face and removed from another. This allows us to get a nice tight corner if we were going to do something like put a weld bead in this corner. Let's take a look at sheet metal gusset. Now inside sheet metal gusset, we need to select supporting faces. In this case, I'll select these two faces. And you notice that by default, it's placing a gusset at one edge. Now we can put a manual offset in here, for instance, 1 inch away from the corner, but the point really depends on your selection. Now we can modify these selections. For instance, we can select a point over here, or you can have points along this line where you can manually place them. Important thing to note is that we do have a lot of parameters that we can modify. For instance, we can make the depth quite a bit bigger, we can manually go in and modify profiles, and we can modify things like the width if we want to make this quite a bit wider. Now the important thing to note here is the sheet metal gusset is actually dimpling or forming this corner. Now you might wonder what this is going to do when you look at it when you flatten it. Well, inside SolidWorks there are a few options. When we go into our options, into document properties, and down to sheet metal, you have some options to show sheet metal gusset profiles when flattened and show gusset centers when flattened. These are very important because when we come in to flatten this part, we really want to see where the center of that gusset is, so it helps with tooling. When you send this information off to any job shop, they're going to know exactly where to put it. For whatever reason, SolidWorks does not turn that option on by default, so if you're using sheet metal gussets, make sure that you go in there, turn that on, and understand what it's doing for you. As I said, there are plenty of other tools inside of the sheet metal suite that you can add to your design to make them that much better. You can quickly and easily add vents based on sketches. You can create forming tools to actually create formed parts as opposed to bent parts. You can modify corners in various different ways, and you can even do some very complicated lofted bends. But these are more advanced topics, and again, we won't be covering them in this series.